proton. Consequently, it's that. So there's so any questions that are on the quiz tomorrow or on the exam, in the first exam, that relate to individual elements. How many electrons, how many protons, what's the atomic mass, any of that stuff is all going to be related to the periodic table that you have access to. So you don't have to memorize it. Just you.
Why?
Because you're Douglas.
Yeah.
All right.
So you don't have to memorize it, okay? But if you go to sodium, if you go to the periodic table and you see sodium, it's on the left-hand side, it's number 11. It's right after neon, which is number 10. Sodium has 3 shells. The first 2 shells are completely full. This is the first shell with 2 electrons. The second shell has 8 electrons. The third shell has a single electron, a lone electron. This is elemental sodium, this red shell. This is table salt sodium. In table salt sodium, it's missing this electron. Where does that electron go? It goes to the chlorine atom, and then it's called chloride. That chlorine atom, which was called chlorine, is now called chloride. No, it doesn't have a positive charge, it has a negative charge. So that, I'm not going to bother drawing chlorine out, but you can do it too. Right? So that, if you add a +1 to a -1, you get a 0. Yes?
Is that a cation?
Excuse me?
Is that a cation?
Oh, a cation? Yeah, this is a cat, yes. Yeah, so it's okay, cation. No, it's okay.
It does look like Cation.
No, so it does, and I've never heard that. I've never even thought about that. It's okay. Yeah, so it's really okay. This is not a class in pronunciation. If you want to make fun of me in pronunciation, I'll say something in Spanish. Okay, so I don't.
Why doesn't it have a space in the middle? It's just
I get fun of
No sé nada. Because just so it's always been like that. It was like that when I was in college. It was like that before I was in college. So the answer is some old dead white guy did it that way, from Germany probably. Well, so there's two ions here. There's a cation. I'm going to start calling it cation now. There's a cation and an anion. Okay, I always just think of that. So the term ion is what I'm really particularly focused on.
So you're telling me any plus is a cat ion.
Anything with a plus, +1, +2, +3 is a cat ion.
That's why I was so confused. I've never heard of that before.
Okay.
Cat ion. Like, wow.
Okay. So,
Continue.
so this is a cat ion. This is an anion. This is not the only anion, right, that exists. If you look at the periodic table, on the right-hand side in column 17, there's a group of very, very electronegative elements called halogens, including chlorine and fluorine. They steal electrons all the time. So in this case, this one steals an electron. This one readily gives up an electron. And so as a result, when you combine these two, you get table salt. When we get into the cell and then into tissues, and then later on this semester, we're going to talk about something called the sodium-potassium pump. When we're going to be dealing with sodium for the rest of the semester. We're never going to be dealing with sodium like this. And I'll show you why in a second. Okay? So, any questions so far? All right, let me turn on the screen here.
That's cool.
Let me see if I can. just tried to turn the air on in here. I don't know if it's gonna work, but we'll see. This is the third time I've been in this room. Okay. So, here's a periodic table. Here's a copy of the periodic table I will give you for the quiz tomorrow and for the exam. Generally speaking, these elements over here on the right-hand side, these elements over here on the right-hand side, not this one right here, will form anions. And if you look at the column here, it stacks here. And whenever they're in a stack, they have the same chemical reactivity. So fluorine and chlorine act very similar. Bromine, iodine, they all act very similarly. These form anions. Oxygen is another example of an element that's very, very electronegative. And so as a rule of thumb, when we're talking about macromolecules, and that's what we're doing today, right? When you see macromolecules, when you see oxygen and particularly pairs of oxygen atoms, that's a very electronegative area of the molecule. And so as a result, there's going to be chemical reactions there. When you see that element right there, carbon, and that one right there, hydrogen, you're going to make something called a hydrocarbon. And when you make hydrocarbons, okay, that's very non-reactive element, or compounds are. So we're going to talk about what those are today. So let's get back to my question about sodium here. So just so you know here, so I drew, so sodium is, atomic number is 11. Its mass is 22.990. I will not ask you without the, so you'll have access to this, to the periodic table. I remember that it's 11 because I only literally care about up to 20. The only other thing that's biologically useful, really, the biggest one is iodine, the element. But we're just going to worry about calcium here. So I just mentioned something called a sodium-potassium pump. Right? There's a sodium and potassium. They're right in the same column there. So as a result, everyone in this column, all of these elements in this column, have a lone electron sticking out way, way, way far away from the nucleus, a lot like this. And as a result, it's very chemically reactive. So the question is, so now, elemental. So this is elemental. Now, all of these will form, what is it, cation? Cation 1 plus 1. This column will form cation plus 1, or cation plus 1. This column will form cation 2, or cation 2. 2 plus, okay? So this is 1, this is 2. So this column will give up 2 electrons, this column will give up 1 electron. Why? Right here, this one only has 1 electron way, way, way far away. This second column has 2 electrons way, way, way far away. Far away from what? Far away from the nucleus. Okay? It would be a little bit like the folks in the back there if I'm the nucleus. Right? You're way far away from me, right? So I can't get to you as well as I can get to these guys. Is there a question back here? Yeah, please.
Does that mean that the other columns are doing all 3, 4?
So these 2 are important, and if you look back at your notes, then we skipped all of these because these are special metals and stuff. Then I started this column right here, 13 through 17, and then I ended with 18. 18 has a full shell, full outer shell. They don't really do much of anything. Neon lights are not reactive because neon is an element that doesn't chemically react. Carbon, if you look at this, there's carbon right here, 1, 2, 3, 4. Carbon has 6 electrons. It needs 4 to get to 10 to be chemically stable. So it can make 4 chemical bonds. If you look at the notes from yesterday, carbon makes 4, nitrogen makes 3, oxygen makes 2, and hydrogen makes 1 chemical bond. That's where I got those rules from. Okay, so all of those rules that I put yesterday, I got based on that. Based on this. Okay? So everything that I talked about and everything that I'm going to be talking about in a matter of minutes is based on this. All right, now, elemental sodium versus ionic sodium. Ionic sodium you already have plenty of experience with because it's in the
with the nutrition you trust.
Here I'm working with some lithium metal, very difficult to cut. I've got a piece of sodium here, pretty easy to cut. And you notice when I cut through that the fresh sodium is very shiny compared to the rest. Let's zoom in real quick and see if we can really get in there. So this side will reflect a lot of light. The other sides are pretty dull. And you'll see that especially with the potassium here. I'm going to go ahead and give this kind of a half cut. So for the potassium, this is the side that's been freshly cut, and you can see the dullness to the other sides compared to that one. So I'm going to go ahead and take those three, and I'm going to add them to water, and we can look at the kind of reactivity of those three alkali metals with water. So here I'm going to take the lithium, and that's the water. It's going to generate hydrogen gas and lithium hydroxide. So you're going to see a pink color develop here, and then you're going to see some smoke come off, and that's either lithium metal or that's lithium hydroxide coming off of there. Maybe a little bit of liquid water. But it's not as reactive as, say, sodium, so I'm going to put sodium into the next one. And the sodium is actually probably going to ignite. So you'll see some orange flame perhaps, or some sparks, or some shrapnel. And then the last one, I'm going to go ahead and put my 2 pieces of potassium in that I've cut in half. So this is less potassium than the other two in terms of amount. You'll find that the reactivity is a little bit greater.
I don't know why I didn't cover that. All right, so what's the difference between elemental sodium and ionic sodium or cation sodium? I'm sorry for making that joke, but what's the difference here? If you were to eat this, you might die. If you were to eat enough of it, you would definitely die. It would react with the water in your body, and it would not be pleasant. Right? There's actually videos online. There's always videos online. There's videos online of people like taking a block of sodium, unwrapping it, and then throwing it in the water somewhere, and it just start reacting. So the external portion of it reacts with what did I just say about oxygen? Oxygen is chemically negative, and if you remember what the chemical formula of water is, H2O. One part of the water molecule, the part that's closest to the oxygen, is very electronegative. That oxygen is trying to steal electrons. If I'm trying to steal this laptop, but this laptop is easier for me to steal, I'm going to say, ah, screw that, I'm just going to take this one. Right? I didn't steal your coffee today. Right? So that's what it's thinking about. What's the easiest electron to steal? That is easier to steal than hydrogen, than hydrogen and water. So as a result, he said that, and I forgot which one it was talking about, lithium, sodium, or potassium, but one of them releases hydrogen gas, and that hydrogen gas then has to also react. The 3 elements that he talked about, lithium, sodium, and potassium, they're all in the same column. They're all in that first column. Okay? Any questions about that? All right, now we're going to start. Let me transition to my notes, my drawings here. It's a picture of my daughter and our dog. My favorite daughter and my human daughter, I like to say. She does not like that when I say it. My human daughter doesn't like that when I say it. Let's see now. All right. So we've been drawing macromolecules, and I'm going to figure out how to upload these today. Let me see. I wonder if there's. But before, I don't know if this is going to let me go any bigger. So I'm going to, what I'm going to do is I'm going to make this, and then I'm going to make a new one, and then I'll save both of them up to the top, to Brightspace. But before I do that, I want to, that's good. I want to just talk about water. Okay, I said that water, and where is it? When I was drawing, right. So this water molecule right here, and this water molecule right here, they have these slight charges here. So this is called delta negative, this is delta positive. This means that the electron these two electrons are spending more time with oxygen than with hydrogen. Why is that? Because oxygen is very electronegative. As a result of that, the oxygen sometimes will have a reversible chemical reaction, and then we have that reversible chemical reaction looks like this. Let me see. Now, when you see that, the two arrows here, one going to the right, the other going to the left, it means that it's a reversible chemical reaction. That water molecule will, every once in a while, that oxygen will steal an electron from one of the hydrogens. As a result, the right-hand molecule here, the right will then form what's called a hydroxide ion. That hydroxide ion is negative, it's got a -1. This H plus has 3 names, and I think I only talked about one name yesterday. So you're going to talk about it being a hydrogen cation or cation. You can hear it talk about being a proton, because if you look at the electron configuration of hydrogen, there's only one electron. This atom of hydrogen has lost its electron, so as a result, there's only a proton left, hence the name. And then the last term is hydronium. So this reversible chemical reaction happens all the time. It's natural. But what happens is that if this hydrogen then encounters something that is much more electronegative, or that has an extra electron hanging around, it will then attach to that. As a result, then we'll be having hydroxide floating around, and that will change something called the pH. The pH of a solution is very, very important. And basically, the pH of a solution goes, if it's high, the range goes from 0 to 14. When you're talking about pH, we're talking about a range from 0 to 14. When you have pH that's about 7, that's about water. Blood is about 7. It might be 6.78, right? It's not exactly 7. But if you do something in your body, like add too much carbon dioxide in your body, what happens is that then, well, there's a number of things happen, but the increased concentration of carbon dioxide in your blood particularly takes the pH from about 7 and it decreases it, and that causes consequent physiological changes in your body, and that's a problem. So pH is incredibly important at the level of the cell and at the level of the mitochondrion, which we're going to be talking about next. The pH, these proton, hydrogen, hydronium atoms, they're ions rather, cations. These things right here, they drive the generation of ATP. Without cations, without those cations, you can't generate ATP. So this is incredibly important stuff. All right, so let me try and do a new one. Let's see. So today, what we're gonna do right now, we're gonna do 2 macromolecules, and then we're gonna take a break, and then we'll transition to the lecture notes. The 2 macromolecules will be lipids, and I'm gonna try to talk about 2 different types of lipids. One is called a triglyceride, and that prefix tri means 3, and the other is going to be a phospholipid. And that prefix phospho means phosphorus, and that's yet another element that we'll talk about. So there's phosphorus and phospholipids, and that phospholipid is, again, is going to be something that we're going to be constantly revisiting throughout the semester. So the phospholipid is important to understand how to draw, but before we go to the phospholipid, we're going to talk about a triglyceride. Triglycerides, if I have 3 fingers sticking out right here, I'm going to draw the main hand right there, and then I'm going to draw 3 fingers off of that. And that's exactly how you draw a triglyceride. So let's see here. So now when you draw a triglyceride and then you draw a phospholipid, you draw 2/3 of the molecule exactly the same. Okay, so I'm going to draw the triglyceride. The triglyceride has 2 main parts. There's first part that's a vertical part that's called glycerol. So that glycerol is the GLYC part of the name. That glycerol is a 3-carbon molecule. Carbon has to obey the bonding rules here. Each of these are H's if I'm not drawing them right clearly. And then there's 3 hydroxyl functional groups. And if you look back in your notes from yesterday, the hydroxyl functional groups are OH or alcohol. So there's an OH right here, an OH right here, and an OH right here. Each of those OHs, I said earlier today that whenever you see oxygen hanging around in a molecule, there's a good bet that it's chemically reactive. And indeed, this is where the chemical reaction occurs. Where are we talking about? We're talking about this first oxygen, the second oxygen, and the third oxygen. Okay, so this is the glycerol molecule. Then we have, let's do this in black. Then we have 3 fatty acids. Fatty acid, the structure of the fatty acid is the same. So I'm going to draw 1 fatty acid, then I'm going to try and copy it, and then I'm going to make a 3rd fatty acid, I'm going to make it different. Okay? So 2 out of the 3 are exactly the same. If I can't copy it, I'll just ask you to do it. So we're going to say 1, 2, 3. Now, the chemical reactivity of a fatty acid occurs at the carboxyl group or the carboxylic acid group. Now, if I were to say that to you in a quiz tomorrow, then you should know that the carboxyl group has this chemical formula. So all carboxyl groups have this chemical formula. And then it's a string of hydrocarbons. Those 3 dots there means and so on. Those 3 hydrocarbons. This is the first of the 3 hydrocarbons that I'm about to draw. There's a lot of, on this molecule on the right-hand side, there's a lot of hydrogens and carbons. And they go all the way out to the right. There might be hundreds or thousands of them. I don't feel like drawing that many. So this part right here is a carboxyl group. This is an alcohol or a hydroxyl group. What are we going to do? What did we do yesterday? We combined, look for 2 H's and an O. So look at that, 2 H's and an O, 2 H's and an O. Doesn't matter which one we get. We're going to get rid of that. What's that process called? Dehydration synthesis, just like we did yesterday twice. So this is the 3rd time we've done that. And then this chemical, this black compound is gonna be bonded to that blue one. And it doesn't matter if this blue oxygen is there or if that black oxygen is there. It doesn't matter, as long as an oxygen is there. Okay, so now let me see if I can do this. I'm gonna just try it once. And if it doesn't work, look at that. Woo-hoo. And then the last one is, let's see here. I'm gonna do this again. Now, for this one, this last one, I'm going to erase this part and I'm going to change it a little bit. So we have two fatty acids that are copies of it, and this third fatty acid is going to be slightly different. Okay, so first thing we're going to do is we're going to have that same carbon and hydrogen formula, but as a result, there's going to be a bend in the atom or in the compound. That bend is going to be caused by this double bond. That double bond where I put that red arrow right there is going to cause the fatty acid to bend. And that bending of the fatty acid is incredibly important for something called a phospholipid. And we're going to build that in a second. So now I have three fatty acids, 1, 2, 3. I have 3 hydroxyl groups on a 3-carbon molecule called glycerol, right? 3 hydroxyl groups. What am I going to do? I'm going to do 3 examples of dehydration synthesis. We're going to lose 3 molecules of water, and then as a result, we're going to get 1 triglyceride. So, go like this to the right. Let's see here. So on this one, I'm going to get that oxygen. On the middle one, I'm going to get that oxygen. And then just that. Yes?
I did 5 carbon instead of the 4.
Where, right here? This, oh, wait a minute. In fact, there might be 500 carbons. There might be 1,000 carbons. So there's a ton of carbons. So it's just that I went 1 extra carbon more. Yeah.
Why the last one it goes from OH to H, but the other two just it takes the whole thing. Like in the middle one, it takes H, HO, but in the other two it takes OH, H.
What's the chemical formula of this? 2 H's and an O, H2O. What's the chemical formula of this? 2 H's and an O. Okay, so it's the same thing.
Is there a difference between OH and HO?
No. Wait a minute. There's no difference provided that the oxygen has 2 chemical bonds and the hydrogen has 1. If you write that there's a carbon bonded to a hydrogen bonded to an oxygen, that's wrong. Okay, so if you're following the rules of bonding patterns, that rule that I wrote in the blue box there, where this hydrogen has 1, oxygen has 2, nitrogen has 3, and carbon has 4 chemical bonds, then there's no difference. If you disobey those rules, then there is a problem. Okay, so it always has to go back to those rules. So does that make sense? All right. So we're going to lose 1, 2, 3 water molecules, and then over here on the right, we're going to make a triglyceride. Okay, it's going to take a little while to draw. I'm going to put right over here 3 water molecules. Now, I'm going to keep the conventional will be the glycerol molecule will still be blue. So the left-hand side of this will still be blue. And then it really doesn't matter, let's see, this oxygen. Bless you. That oxygen is the remnants of what is remaining right here. So that red oxygen is from right there, that red oxygen is right there, and that black oxygen is right there, okay? So there's 3 oxygens left, and then what do you do here? Then I copy the rest of this and I put it over here. I copy the rest of this, I put it over here, and I copy the rest of this and I put it over here. I'm gonna try and do that, just to see if I can.
So
you use
that
that.
whole thing?
Excuse me?
Read that whole thing over the triglyceride?
3 of this whole thing is called a triglyceride, correct?
Dr. Prince.
Yes.
Use out of the O's. Use out of 3 oxygens.
Excuse me?
So you just added 3 oxygen molecules.
Did I what?
3 oxygen
Yes.
molecules, right?
Yes.
And then.
Hold on a second, let me finish this. So it's not perfect the way that I'm drawing it. So let me see here. I'm going to draw a chemical bond between the oxygen and the carbon, between the oxygen and the carbon. So this is called a triglyceride, right? So this oxygen is bonded to this carbon, this oxygen is bonded to this carbon, that oxygen to that carbon. If I drew it correctly, and I'm going to check this in a second, all carbon should have 4 chemical bonds, oxygen have 2, hydrogen should have 1. Except on the right-hand side, which is basically what, and so on. Okay? Yes? Oh. All right, so. 1, 2, 3. I think that's right. It's not very messy. It's a little messy. So this is a triglyceride. The triglyceride has 3 parts to it, well, 4 parts to it. There's 3 fatty acids and 1 glycerol molecule. When they're bonded by dehydration synthesis, then you have, you're making something, you're building something up. There's a little bit, it's not quite the same as a monomer of an amino acid, but it's similar, it's analogous to it. The monomer of a protein's amino acid, we talked about that yesterday. The monomer of a carbohydrate is a monosaccharide. We talked about that yesterday. We don't really have monomers in lipids. We have glycerol molecules in fatty acids, or glycerol molecules and then another thing, and a phosphorus group, okay? So this is a triglyceride, okay? So now what I'm going to do is I'm going to copy this part right here, put it down here, and we're going to make a phospholipid. Okay? Same process that happens. So the reason why I can copy it is we're doing the same thing. Now, if you notice here on the left-hand side, upper left-hand side, it says 3 fatty acids. I'm going to copy this picture right here. I'm going to copy a glycerol, 3 fatty acids. Oops. Okay, now, if I wanted to make a triglyceride, I would have 3 fatty acids. What I have there. I don't want to make a triglyceride. I want to make something called a phospholipid. So I'm not going to have 3 fatty acids. I'm going to have 2. So what I'm going to do is I'm going to take this one right here, and I'm going to erase it. I'm going to erase that 3 right there. I'm going to change it to 2. And then we're going to have another element on there because we still have to have something bonded here. Okay, so the rest of the molecule is going to be exactly the same. So that first fatty acid here, so we're going to take this. We're not going to make have 3 fatty acids. We're going to have 2 fatty acids. Okay. So we have, 2 fatty acids on the right side. We have that glycerol molecule in the center in blue. We have dehydration synthesis happening here. And I'm going to erase that one. We have 1 fatty acid with no double bonds here, 1 fatty acid with a bend with a double bond there, and that double bond causes it to bend and act a little differently. If you look over here on the left, there's a P there, and that P is shorthand for a phosphorus bonded or double bonded, depending on how you organize it, to 4 oxygens, and then there's a bunch of elements there. There's a bunch of other things about it. I don't really care about that. So what we're going to do is we're going to say instead of phosphorus, we're going to say that's a phosphate group. So now whenever you see a P with a circle in it, you're going to call that a phosphate group. And that's what that says, phosphate group. And don't worry about the elements in there. I'm not going to ask you about the chemistry of it. I'm not going to ask you about anything. Okay? So now I'm going to just organize this a little bit better. I'm going to erase this. I'm going to make a chemical bond here. I'm going to erase this. I'm going to make a chemical bond there. I'm going to erase this part because we already know about dehydration synthesis. Okay? So I'm going to so this stuff in red I'm going to erase because we've already done with dehydration synthesis. So now the glycerol on the left has to be bonded to these 2 fatty acids on the right. And the chemical bond will be like that right there. And the chemical bond will be that right there. So I've gone from a triglyceride to a phospholipid. That phospholipid has phosphorus on one side, or phosphate group on one side, and the 2 fatty acids on the other side. The phospho part has 1 type of chemical reactivity. The lipid part has another type of chemical reactivity. If I took a glass of water and I put cooking oil in it, I put vegetable oil in it, I shook it up like crazy, and then I put it on the desk, what would happen? It would separate. Why? Density, but what else?
No, water and oil don't mix.
Excuse me?
Water and oil don't mix.
Why? So you're right, but why?
Is it not pollution?
So this part right here, the chemical nature of oil is this: hydrocarbons, carbons and hydrogen sharing electrons equally. The chemical nature of water is that they don't share electrons equally. So as a result, that oil, cooking oil, whatever, vegetable oil, whatever oil it is, separates from the water. The water gets repelled, or the oil gets repelled, whichever you want to talk about. They don't like each other. That's what happens here too. This part right here is called hydrophilic. What's this? Hydrophobic. Okay, the prefix hydro means water, water loving, water fearing. All lipids are hydrophobic.
Lipids? All lipids are hydrophobic?
Yes. Okay, so the phosphate group of a phospholipid is hydrophilic. The lipid group of, or the fatty acid group of a phospholipid, or the lipid group, is hydrophobic. When you look back at proteins here, some proteins will have cations or cations and anions. Other proteins will have fatty acids on it. Those fatty acids will act more like hydrophobic, and anything with an anion or a cation on it will act hydrophilic. So yesterday I was talking about the differences in the amino acid structure in your hairs, in your various hair structure. There's another example here. So you have some proteins that will act hydrophilic, other proteins will act hydrophobic. Okay? And depending on where they are, then they have particular jobs to do. Okay. Yes?
For the second fatty acid, when did the double bond occur?
So we have there's a so this bond right here, this one right here is called a saturated fatty acid. This one is called an unsaturated fatty acid. So during metabolism and things like that, when double bonds occur between adjacent carbons here, that's an unsaturated fatty acid, and as a result, it changes the angle of the carbons. So when does it occur? It happens naturally. Okay. If this is too much for you, right? I said last week, we start off very fast, and if this is too much for you, in the October and November, you're going to be wishing to come back to this. This is easy. Not only that, if we were down on the main campus, I wouldn't even bother with this stuff. Right? I would assume that you know it, and if you don't know it, you'll struggle to figure it out eventually. And by the way, it is going to be over a quarter of the first exam. Okay, and then it'll be tomorrow too.
Okay.
Okay? So, last macromolecule. What is the last macromolecule? Say it. Nucleic acid. So there are 3 main nucleic acids. You guys know 2 of them definitely. What are they? So DNA, RNA, or ribonucleic acid, deoxyribonucleic acid. Anyone know what the third one is? There's more. ADP and ATP. If you look at the last one, ADP, ATP, right? What does that P stand for? This is energy. What does that P stand for? You see that I have that P in red? That phosphorus group, that phosphate, when you add it to a third adenine here, when you add, a third one to an adenine, you get ATP and you can generate chemical energy. So that phosphorus group is something that we're going to deal with today. We're not worried about lots of drawings of this one. I've talked about 4 macromolecules. I've talked about proteins, carbohydrates, lipids, and now nucleic acids. So this is the 4th. 3 of those, proteins, carbohydrates, have a monomer. Protein has amino acid. Carbohydrates have monosaccharides. All right? It's important to understand how you draw those, how you recognize those, and how you can make chemical bonds with those, right, through dehydration synthesis. Lipids are a little bit different. We made 2 different types of lipids. I'll talk in a little bit about other types of lipids, in particular cholesterol, testosterone, estrogen, things like that. There's lots of different types of lipids in your body. What I'm going to do now is when we talk about nucleic acids, we're going to talk about the monomer of a nucleic acid, and that's really all we're going to talk about. Right? In terms of the function of nucleic acids here, where do you see DNA? Where do you find DNA in your body? There's one place and only one place. In your nucleus of your cell. Where do you find RNA in your body? So that's ribosomes consist of RNA, but RNA is assembled in the nucleus and then shipped out of the nucleus. So if this is the nucleus of a cell, like this room is the nucleus of a cell, I'm the boss. You guys are my RNA molecules. Once I finish building you, I'm going to get you the hell out of here. Right? And then you go off and do, the RNA goes off and does stuff. Anyone ever hear of RNA vaccines?
No.
People always say, RNA vaccines, I don't want them to change my DNA. Okay, that's fine. Right? The cells are built so that they don't allow RNA back into the nucleus. We'll talk about that in the next. Yeah. So RNA doesn't get back into the nucleus. RNA gets assembled in the nucleus and then shipped out. It's a one-way street. You don't get back in if you're RNA. So your body is designed through evolution to prevent stuff from getting into your nucleus. It's really bad to get into your nucleus. Your cell doesn't want anything in your nucleus except for DNA. So we have DNA that's found in the nucleus, RNA that's built in the nucleus and shipped off into the cytosol or the outside of the nucleus. And then we have ADP and ATP. ADP is the non-energetic form. ATP is the energetic form. They are chemical energy. Does anyone know what A is in ADP or ATP?
Adenosine.
Adenine. So adenine is part of when you're building nucleic acids. So the monomer of a nucleic acid is called a nucleotide.
Those are the easiest ones. I'm not
The nucleotide has 3 parts to it. 2 parts that you guys are genetically identical to me on that. And how many of you want to be genetically identical to me? To an old white guy with no hair, right? You do? Well, no, so you are absolutely, everyone in this room is genetically identical to each other with this first part of the nucleotide. right? And I dare say none of you are genetically identical to anyone, right?
Okay,
So what do I mean by that? The nucleotide has 3 parts.
Wait, is this for DNA?
This is for DNA, RNA, and ADP and ATP. Particularly for DNA and RNA, this first part, the first 2 parts, the left-hand side, I'll number it 1. And that one right there, that P is a phosphorus group or a phosphate. And how many carbons does that right number 2 molecule have? 5. So that's called a pentose sugar. If this sugar has oxygen, then it's RNA. If it doesn't have oxygen, it's deoxy. It's DNA. Right? We're not going to worry about the distinction between that. Okay? This is all that so this is a pentose sugar, 1, 2, 3, 4, 5. This is a phosphate group. Right? And then off of this carbon right here, then we have the thing that really determines us. And the thing that really determines us, whoops. So there's nitrogenous bases. So there's 3 parts to a nucleotide. There's a phosphate group, a pentose sugar, and then one of 4 nitrogenous bases. 4 nitrogenous bases come in either 4 different categories, right? There is either 4 for DNA, 4 in RNA, in particular for DNA. Now, you have 2 different organizations of nitrogenous bases. So you can have a wide nitrogenous base or a narrow nitrogenous base. And I'm just going to draw one example of a nitrogenous base. I sketched it out in my notes, and I don't remember this one, but I'll show you this one in the lecture. So wide nitrogenous bases have 2 rings, and that prefix nitrogenous means there's lots of nitrogen in it. The one narrow one has a single ring. Okay, so you should be able to recognize these. You don't have to identify the names, but if I say this is cysteine, what's the chemical formula for it? You should be able to tell me that. Okay. So what is an example of that one? Oh.
These were wide movement. How is this?
Good question. Let's go over that in 1 second. Oops. Okay. So first of all, this is an example of a nitrogenous base. You might find this you definitely find this in your DNA. The difference between your DNA and my DNA is just the order of these nitrogenous bases. That's the only thing that's different between us. And in fact, that's the only thing that's different between you and my dog, you and a tree, you and an earthworm, right? There's other things too, but pretty much the order is the fundamental part. This is a chemical, this is one example of a nitrogenous base. Now, if I show you this tomorrow, and let me restate that, when I show you this question tomorrow, or something like this, what's the chemical formula? So, I want you guys to tell me, first of all, what are the elements that are in this molecule?
Nitrogen.
So, I don't. Carbon, nitrogen, and what else? Carbon, nitrogen, and hydrogen. Anything else? No. So.
Carbon, nitrogen, and hydrogen.
That's right. How many carbons?
Zero. Five.
You don't see any carbons. You don't see any C's in this, and yet there are carbons there. 1, 2, 3, 4,
Oh,
5.
it's the dot system. Let's see.
Also thoughts.
Right? How many nitrogens?
5. Oh, wait.
1, 2, 3, 4.
So
4.
carbon is right here. That dot, that circle is a carbon. So there's 1, 2, 3, 4, 5 carbon. 1, 2, 3, 4, 5 nitrogen. 6 what? Oh, 6 hydrogen. Okay. Wait a minute here. Wait a minute. This isn't right. Why is that right? Why is that? Why did I say this isn't right? Because this carbon has 4 chemical bonds, so I messed that up.
Oh.
This carbon has 4 chemical bonds, so there has to be a hydrogen here as well. Now, this carbon right here, 1, 2, 3, 4, so that's okay. So I have to add one right there. This nitrogen, right, 3 single bonds, so that's fine. Look at this nitrogen here. There's no hydrogen hanging off here. Why? Well, because there's 1, 2, 3 chemical bonds. So this nitrogen's fine. That hydrogen, I have to add another, that carbon, I have to add another hydrogen to.
Isn't that a nitrogen?
Which? Right there?
No. That one.
So there's 8
Oh, okay.
hydrogens.
Okay. All right, so there's 2, 3, 4, 5, 6, 7. 2, 4,
3, 4, 5,
2,
6,
4,
7, 8. 8.
6, 7.
How are you getting 8?
How do you get 8?
6. Is it?
So there's 1,
Oh.
2,
Never mind.
4, 5, 6, 7.
I was for some reason counting the N as an H. I don't know why.
Okay, so the chemical formula of this is that. I might show you a double, this is 2 rings of a nitrogenous base. I might show a single ring of a nitrogenous base. If it's 2 rings, it's wide. If it's 1 ring, it's narrow. Okay? So, we've talked about a lot of stuff over the last day. Right? A lot of different topics. And there's 2 ways that I could have done this. Well, 3 ways actually. One way is just by lecture. Another way is by a long school, year-long thing of chemistry, right? And the last way would be just to ignore it completely and say, you guys are on your own, figure it out. Okay, I'm trying to sort of do something in the middle. I can tell you that we're going to be talking about cations and anions, cations for the rest of the semester, particularly the sodium-potassium pump. I'm sorry for making that joke. I like that. So this is really, really critical. Question?
So that's the wide nitrogen.
Nitrogenous base.
That's the wide one.
Yep. So this is the more complicated one. The simpler one is just easier.
So like, what would you say is like really important to know for the quiz tomorrow based on what we just went over?
So what is important on the quiz? Well, first of all, I'm going to jump into the lecture in chapter 2. So basic parts of the periodic table, cations and anions, subatomic particles, etc. Bonding patterns and chemical reactivity, water, macromolecules.
Could you go slower?
Hmm?
Could you go slower?
Yeah.
So I can, but I have to get through all this material. So you have to figure out a way to keep up, right? So that's another thing. Why is it that I want to be with you guys? I don't need to be with you. If URI wanted me, if I just said, I'm going to teach a URI class for you guys, you know how many hours a week we would be in lecture? 3. 3 hours a week. What we did today is beyond one lecture. Hold on a second. So 3 hours a week.
Am I missing one?
Bonding patterns, chemical reactivity,
So if you want me to go, if you think I'm going fast now, go down to the main campus, or even CCRI Rick is going to be the same way, right? They're going to go through really basic stuff at the start. Here's a basic thing. Here's a little. I could do this whole lecture in 15 minutes. Right? Or I could completely ignore it. So you guys have to be up on top of this stuff. If you're not ahead, then you're behind. If you haven't already looked at this lecture material, then you're behind. Okay? And by the way, there's other things that we're getting into. We're going to be getting into cells tomorrow, and we're going to do the same thing. I'm going to use this what you call it? You do? All right. So once again, my job tonight is to upload this picture and the previous picture, and I have it saved. I just got to figure out how to do that. Okay? So give me, let's see here. It is now
30 minutes.
My wife says hi. Good morning. I love you.
Always welcome you.
No, it's said to me, not to you. And my dog says hi too. All right. So it's 9:34. Let's take 10 minutes. 9:45. Okay.